Hello and welcome to this BioProcess Insights webinar. I'm your host, Leah Rosen, the online editor for BioProcess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for our speaker in the chat window on your screen. After the presentation, we will begin the question and answer portion, and I will ask our speaker your questions in the chat window. Your questions in the chat window will only be visible to myself and our speaker. Thank you for joining us today. It is now my pleasure to introduce our speaker, Dr. Bill Flanagan from GE.
Hello and good day. My name is Bill Flanagan. I lead GE's Eco-Assessment Center of Excellence. I'm also the chair of the board of directors for the American Center for Lifecycle Assessment, which is the professional membership association for lifecycle assessment in North America. My role for GE is an interesting one. I don't work for any of the specific GE business units, but I work at the corporate level providing environmental sustainability insights to many of GE's products and technologies. A big part of my role is outward facing and interfacing with customers and other stakeholders. But another part of my role is really focused inward in providing environmental sustainability insights to our product development teams as they embark on new technology development journeys. So today we're going to talk about environmental sustainability as it relates to single-use technologies. And we're going to talk a little bit about some of the business drivers we're seeing in the biopharmaceutical industry today, how this relates to the adoption of single-use technologies to lead to desirable outcomes, the relationship between the adoption of single-use technology and sustainability. We're going to talk about a new environmental life cycle assessment study that we're currently performing in the context of being able to provide insights for manufacturers to help guide them in their single-use journey. And of course, at the end of today's discussion, we will have time for questions. So from an industry standpoint, there are a number of really strong macro trends that manufacturers face in pursuing new molecule development and commercialization. And the combination of these have led to multiple outcomes that are real challenges for the industry. And so one of the things that we're seeing is that there are fewer blockbuster molecules. The focus is now much more on targeted therapies. We're also seeing a lot more focus on novel biologics such as biosimilars and the increasing competition around that space. Of course, we always are dealing with relentless cost pressures, perhaps more now than ever before. And then we also see a trend towards globalization, so locating manufacturing much closer to the served region. So as a result of all of these, manufacturers are looking to do a lot more with their existing footprints, looking for higher productivities and utilization rates for existing capacity, to be more nimble with their current assets, and to be able to deploy multiple molecules within a pipeline in the same facility, and with the eye towards developing more robust processes with lower variability. So single-use technologies, if you're not already familiar with these, are fluid path components that replace the traditional reusable stainless steel components. So in other words, bags and chambers, connectors, tubing, filter, capsules, agitation system, cross-flow filters, sensors, for example. And the adoption of single-use technologies over the past decade has enabled biomanufacturers to achieve many of the desired outcomes. And what we're looking at here is a generic biologic manufacturing workflow upstream through downstream. And so the evolution of single-use technology has allowed essentially single-use implementation, not just in secondary operations like media and buffer preparation, but also in the seed train, production, and all the way through downstream purification steps. So GE Healthcare has extended its single-use offerings beyond simply the provision of single-use and traditional equipment to bioprocess knowledge solutions across the entire process train. So what are some of the benefits of single-use technology? So today's topic is really going to be focusing on the sustainability aspects. But we know there are also benefits around flexibility of the manufacturing operations and ability to decrease the intensity required around cleaning and sterilization between batches. And all of this leads to process economy as well. So why are we looking at this now? One of the main reasons is that, from my vantage point working at a corporate level in GE, I'm always very interested anytime we're developing new technology that is significantly different than the incumbent technology. In other words, technology shift. And whenever we see technology shift, my view is it's important to really understand the environmental implications, any trade-offs or burden shift associated with that industry shift. And so today we're going to be really exploring the industry shift around traditional to single-use technology and how that impacts our operations from a sustainability perspective. And to do that, we're going to be leveraging a methodology known as environmental lifecycle assessment. This is a very powerful systems-level perspective that allows us to look at the entire value chain of the two different technologies, traditional and single-use. And so it's very important to understand this is a holistic perspective from two very important angles. And one angle is that we look at the entire value chain from cradle to grave. So we start with extraction of materials from the earth, a refining of those materials, manufacturing of the hardware, of the components, the consumables, transport of all of those throughout the supply chain and to the point of use. What happens during use of the BioProcess technology, and ultimately the end of life or disposal mechanisms for both hardware and consumables. So we really leave no stone unturned in looking at all of that. The other important angle to be aware of is that you may be aware of carbon footprint, which is a very similar methodology. But here we're looking at a wide variety of environmental impact categories, not just carbon footprint. And this allows us to understand if there are, when you move from traditional to single use, if there are burden shifts from one environmental impact category to another. And the reason this is important is when you're involved in a big technology shift, we want to see where all these changes are so we're not falsely optimizing based on a single metric or a single life cycle stage, for example. This can be a very powerful perspective to bring to bear, especially when we're comparing two technologies. The insights gained through life cycle assessment can support our decision-making processes, allowing us to evaluate alternatives, prioritize opportunities for improvement, and where we see environmental issues, give us a roadmap for how we can begin to mitigate some of those environmental issues. I'd also like to mention that although we're mostly talking today about a comparison between single-use and traditional technologies, the insights gained in this modeling can be used to shed insight on hotspots, for example, within a single technology path, within a traditional bioprocess operation, within a single-use bioprocess operation, or even within a hybrid operation. So it's a very powerful approach. We actually performed a very detailed life cycle assessment study several years ago. And at that time, we were looking at the currently available technologies, primarily the wave bioreactor system, along with the ready-to-process full process train for monoclonal antibody production. At that point, when we started that study, we weren't quite sure what to expect. Many of us in the industry were actually speculating that as you move from reuse of existing equipment through cleaning and sterilization to single-use technologies that involve one-time use of disposable attributes, that maybe this isn't the right choice for the environment. But we did the LCA study because we wanted to understand that to identify mitigation opportunities. What we found instead was rather unexpected and counterintuitive. The detailed life cycle assessment study revealed to us that in every one of the 18 environmental impact categories that we looked at, single use exhibited lower environmental impacts compared to the traditional technology. And we also found that the end-of-life impacts, which is where we sort of had speculated the impacts would be, the end-of-life impacts were negligible compared to, for example, the use phase and the supply chain. And why is it? Why did we experience this result? So the main driver for this was when you go to a single-use process train, you have an opportunity to significantly reduce the amount of water for injection, the amount of process water, the amount of steam, the amount of energy involved, not only in the process, but primarily in the sterilization and cleaning operations in between batches. So again, it was an unexpected result, and it was the type of result that was really only accessible through the application of a detailed life cycle assessment. Now, we're here today to talk about the evolution of what's happening in the bioprocess space. And so we've decided to embark on a new LCA study. And I want to talk through a few of the reasons why we're updating our study. One is some of the trends we referred to earlier, the expansion of single-use capability into new geographies. So we'd like to understand, does the installation geography impact the environmental sustainability of the single-use operation? We're also seeing a trend towards the increased use of facilities with optimized floor plans. For example, GE Healthcare's modular Cubio facility. We now, compared to a few years ago, have a broader range of single-use technologies, so we want to update our study to look at those. And to be honest, our new study has really been motivated by very strong customer interest, manufacturer interest in the LCA results that we had published previously. And it was clear to us that these insights were very important to manufacturers, were an important part of their decision-making process, but their decision-making needs have evolved. And so we're getting a lot of requests from Big Pharma to update our LCA study specifically to provide them with the more advanced insights that they need. Meanwhile, as we've seen the industry evolve towards improved potency, improving yields, more niche molecules, the average scale has decreased. And so we have a much broader reach of single-use technologies into the scales that are of interest in today's evolving world. So what's different about the previous study that we talked about and the new study that we're talking about today? So the previous study only really looked at monoclonal antibodies. The new study is going to update and expand the monoclonal antibody study, but we're also going to be looking at a vaccine process. The previous study looked only at the traditional stainless steel versus the single-use retrofit scenarios. The new study will look at both of those, but we'll also look at the single-use facilities with an optimized floor plan. And also we'll look at hybrid scenarios, because one other aspect that's evolved is many manufacturers are actually using single-use technologies almost ubiquitously, even in what are otherwise traditional process technology or process scenarios. The previous study only looked at the wave bioreactor system and the ready-to-process portfolio. The new study will incorporate the Accelrex bioreactors, the wave bioreactor system at the 25-liter scale, the high clone growth and buffer media portfolio, the actor-ready chromatography systems, and of course the ready-to-process portfolio. The other things that we're incorporating into the new study, as I alluded to earlier, are looking at what is the effect of the installation geography, which of course impacts the energy grid when electricity is being consumed, and also transport impacts. And then we're also going to look at a wider range of end-of-life disposal options. So today we're going to talk a little bit about only preliminary results from the very first phase of this LCA study that we expect to extend throughout 2016. So today we're going to talk about a traditional stainless steel facility versus a single-use facility in a retrofit traditional facility. And then we're also going to look a little bit at what's different if you design the single use into a facility with an optimized floor plan, such as a modular Cubio facility. We're going to be looking at monoclonal antibodies just at the 2 by 2,000 liter scale. Our assumed titer here is 6 grams per liter, and we're looking at a 10-batch campaign. We have a very impressive set of participants in this study. Myself, I'm involved from a lifecycle assessment and project management perspective. We have a wide variety of expertise within GE Healthcare, not only around the equipment, but also around the bioprocess expertise itself. This time around, we're also collaborating with Quantis International, which is a world-class LCA consulting firm. And then we also have substantial participation from Biopharma Services, who are doing a lot of the custom bioprocess modeling for all of the scenarios that we're looking at. I want to mention that the previous study that we did went through exhaustive third-party critical panel review and peer-reviewed technical publication. We're going to be doing exactly the same thing with this study as the various pieces become available. Today we're only talking about preliminary results, but by the end of this journey we will have exhaustive critical review performed. So let's make sure first, before we talk about results, what exactly is included in this study and how granular is our modeling. So this first systems diagram really looks at the traditional bioprocess. And so when you do a life cycle assessment study, the system boundary, which is indicated by the blue dotted line, really encompasses everything. So it's building the hardware, starting from raw materials and manufacturing, including transport, as well as all of the consumables that are required for a traditional bioprocess. We account for all of the energy and water. We account for the buffer solution and growth media. And then coming out of bioprocessing, we account for wastewater disposal, what happens to the hardware and consumables at the end of their useful lifetime, and of course the product goes on to commercial use. Now contrast this with a single-use system diagram, and the only thing that's different here is we have all of the same features before, but now we've added the single-use materials. Again, raw material extraction through manufacturing, through delivery to the bioprocess itself. And then we also have to account for the single-use materials at the end of their life, so disposal. So again, we're looking at everything basically. Now, one of the things that's important to understand is that we are also looking at the bioprocess from a unit operation specific perspective, because again, we want to understand where the impacts are coming from on a unit process by unit process basis. And so this is an expanded view showing the bioprocess itself. This is a representative diagram. The actual bioprocess unit operations do change slightly as we explore different process scales, and obviously when we get to the virus case study later in the year, there may be some unique unit operations involved there. But this is just, again, an example to give you a flavor for the granularity of the modeling and the richness of the results that we'll be having access to as the results become available. So in terms of the methodology and getting ready to do a life cycle assessment, we first start with collecting the data. So all of the data that are within those system boundaries that we just looked at, we call that the life cycle inventory, LCI. So here we're going to collect all of the bioprocess modeling data, all of the single-use materials production data, the single-use material and hardware disposal data, hardware production data. We have region-specific energy grid data, region-specific single-use and hardware transport data. So all of these data are collected, organized, and then put into the LCA modeling. And in this particular case, we're using an impact assessment method called Impact 2002 Plus, which is a world-recognized method. So all of the data come in from the left, and the methodology calculates the environmental impact in a wide variety of what we call midpoint impact categories, which are then further aggregated into damage categories, for example, human health, ecosystem quality, resource, and we also look at climate change separately. So the main things we're going to be thinking about during this study at this point are the midpoint categories. For example, everybody wants to understand carbon, energy, and water implications. And then we're going to focus more specifically on the damage categories of human health, ecosystem, and natural resources. When we get further into the project and start doing more detailed technical reporting, we'll also be talking about some of the more granular results from a midpoint impact category perspective. So now let's get into what some of the results will look like for this 2 by 2,000 liter monoclonal antibody process. And we're going to do this a little bit differently than maybe we did the first time around, or we typically do from a scientific reporting perspective, because the study really evolved because of requests from customers for key insights that they need for their decision making. We thought that today we would engage a similar story arc and really kind of give examples of how the modeling can be useful to address different questions from a different perspective. And so we've hypothesized 3 different bioprocess perspectives, and we'll walk through what the model can do to address some of those questions. So the first one, imagine that you're a US-based medium-sized biotechnology company and you're expanding capacity, and you're considering expanding into single-use capacity rather than traditional capacity. So you might be asking yourself, does the increased use of plastics or disposables mean that my environmental impact will increase? And of course, this is one of the primary things that the comparative life cycle assessment model can answer. So here's a preliminary result really looking at the comparison of a traditional process with a single use in a retrofit facility. And we're going to talk about these in terms of radar plots. And so this radar plot, essentially we are plotting the higher impact of the 2 technologies, in this case traditional, on the periphery of the diagram, so normalized to 100%. And then relative to that is the single-use retrofit indicated in the inner pentagram in the orangish color. And so as you move to the center of this diagram, you are looking at lower impacts. So in each of the 5 impact categories we've plotted on this page, you can see that the single-use retrofit scenario has anywhere from 30 to 60% reduction in impacts across the life cycle for each of the 5 environmental impact categories. So very interesting result. And this is very consistent with what we found in the first life cycle assessment study. So the next question we might ask is, well, I'm expanding capacity, but I'm not going into a retrofit facility. I'm going to actually develop a new facility with an optimized floor plan. And when we do that, we see there are further reductions in life cycle impact. And the only difference between these 2 scenarios, the single-use retrofit versus the single-use with optimized floor plan, is that with the optimized floor plan you have better efficiencies with respect to heating and air conditioning. And so you can see there's a small but noticeable improvement from that perspective. And then we can also look at these impacts and how they distribute across the different life cycle stages. And we've simplified the life cycle stages here. We're just looking at supply chain versus use versus end of life. And what we see here, again, we're looking at each cluster of 2 bars is one of the 5 impact categories. And we're looking at traditional versus single-use retrofit. And you can see the blue sections of each bar represent supply chain. The orange sections represent use, and the red represents end of life. So there's really 2 key things we can derive from this result, is that the single-use process scenario has a larger share of impact in the supply chain, but greatly reducing the impact in use. And the net result of that is a significantly lower life cycle environmental impact. The other thing to note on this slide, which we also saw in the first study, is that the contributions to impact and end of life are really very small compared to the entire life cycle impacts, which again was a very important insight, that most of where we tend to focus perceptually is end of life, whereas if you really look at it, most of the important impacts are occurring during use phase and supply chain. So let's move on to a second scenario. And now imagine if you are a large multinational biopharmaceutical company and you're expanding globally. So you're going to be putting installations in different geographies. So what are the regional impacts and how might that affect my water and carbon and energy footprint? So the model has the ability to look at that as well. And so here are some preliminary results. We've handpicked sort of 3 representative and relevant geographies: Boston in the US, Shanghai in China, and Dortmund in Germany. And what you can see is that in each case, the traditional bioprocess scenarios have larger impacts compared to the single-use scenarios, but that the relative savings really vary, and so very dependent on the geographic location. And although these three relevant locations all show that single-use is less impactful than traditional, we need to be careful here that the results we're showing are only specific to those geographies. We may find other geographies where we might not have as much of an advantage for single use. But the intent of the model is to provide those insights to manufacturers. And you can see very similar results here for non-renewable energy demand. Again, the energy use savings really vary depending on the location. And pretty much the same thing with water. So very similar results. Our third scenario, imagine you're a large multinational biopharm company and you're upgrading your existing stainless steel process, but you're looking at this from the perspective of your sustainability development goals as a company, for example. So how will this move impact your carbon footprint, for example? So one way we can look at this is we can set the baseline. Suppose you have a traditional bioprocess, again, this 10-batch campaign at 6 gram per liter titer for monoclonal antibodies. And you have a traditional operation, so that's your baseline. So we call that 0% savings. And then suppose we convert that over to a single-use retrofit. So the model is going to tell you that you're going to achieve almost a 31% savings in carbon footprint for that particular process. And then let's add recycling. Instead of incinerating, for example, the cell bags and other single-use components at end of life, let's recycle those. And you see a small improvement. And again, remembering back a few slides earlier that the end of life impacts are relatively small relative to the life cycle perspective. And this is a life cycle result. So that explains why it's only a minor improvement there. And then if we go to, instead of a retrofit, let's go to an optimized footprint single-use facility. And you can see because of the optimization in heating and air conditioning, we get further improvements. And then we further attach recycling operation to that, and we get a little bit further improvement. And again, these are just representative results. These results are specific to the North American East Coast geography at the 2 times 2,000 liter processing scale. And as we start looking at a wider variety of scales and a wider variety of geographies, we will get different results. And so, but that's the point of the modeling, is to really be able to dive deep and provide those kinds of decision-making insights that are needed by manufacturers. So as we conclude our discussion of the first phase of this project, what we've seen so far very much correlates with our previous LCA results, that for the scenarios that we've looked at so far, the single-use process technology does exhibit lower life cycle environmental impact compared with the traditional technology. The end-of-life contributions are pretty small relative to the overall life cycle environmental impact. As we start looking at different installation geographies, we see that the single-use technology exhibits varying levels of environmental impact benefits, so very geography specific. And then we're also starting to look at the results from the perspective of corporate sustainability development goals. And again, let me just reemphasize, the sustainability profiles are really process dependent. They're dependent on scale. They're dependent on geography. So as you have questions, feel free to engage our team as we go into the next phase of the study. So where are we headed next? The next phase of the study is, again, focused on monoclonal antibody, but we're really going to look at a wider variety of process scales. And we're also going to look again, here at the hybrid configurations that are a combination of stainless steel and single use. There is no one defined process configuration that's hybrid. Every manufacturer might have their own definition of that. So we're going to try to have the ability to look at various hybrid configurations. And then as we move further into the study, we're going to extend into looking at some vaccines, and these will be at a smaller scale. And again, I want to mention that although I'm talking about this right now from a comparative perspective, really looking at the difference between traditional and single use with optimized floor plan and hybrid, The LCA model can also provide very valuable insights even if you're invested in a single type of process technology. We can do hotspot analyses to try to figure out, well, where are the impacts coming from within that process. So as we reach the end of this discussion journey this morning, I turn the question to you folks. I mean, what is your scenario? What kind of questions do you have? What kind of insights could our LCA modeling provide to you that would be helpful for your decision-making needs? This is why we're here today, to sort of reach out and engage. Feel free to contact us. If you have access to your local GE healthcare representative, they can find us and put us in touch for a follow-on discussion. So before we moved into the Q&A, I just wanted to acknowledge we have a very impressive team of participants working with us. This is one of the best projects I've had a chance to work on in recent years because of the caliber of people we have here. We have Adriana Lopez and Andrew Sinclair from BioPharm Services providing really expert knowledge around the different bioprocess configurations. We have world-class LCA modeling capability from Quantis International. Carter Reeb is our lead analyst, guided by John Bettling. And then we have deep expertise in GE Healthcare, Amit Dua, Bill Whitford. And then we also have Johan Rosenquist, Mia Benamo, and Carolina Bosan, who are very much familiar with our Cubio facility and have done quite a bit of modeling around that scenario and providing input for us. So with that, I thank you for your attention, and we'll open this up for some questions.
Thanks, Bill. So we do have a couple questions to start with. Did the 2010-2012 LCA include water consumed by the single-use equipment manufacturer?
Yes, that's a good question. So all of those details are available in a variety of publications, but the answer is yes. We looked very closely at carbon, energy, and water as in addition to the wide variety of environmental impact categories that we showed on that one slide. But yes, we looked at freshwater consumption.
Okay, and actually just apologize, we also have Amit Dua here today to help answer questions. So I just wanted to introduce him in case you hear his voice come on as I'm asking Bill these questions. So the next question we have is, do you have LCA data reflecting campaigns with different numbers of batches? As the batch number rises, does the single-use savings decrease?
Yeah, that's also a good question. No, we feel that the selection of 10-batch campaign is a good representation, and all of the impacts or inputs to the system, obviously the equipment exists for much more than just 10 campaigns. It's all allocated or prorated to the 10 batches, and so as you extend into longer batches, everything just expands fairly linearly. So the savings would be proportionally the same with just continued use.
Okay. And which of the 5 impact categories includes disposables recycling of the single-use equipment?
Yes. So essentially, the end-of-life impacts are displayed in all of the impact categories we look at. So for example, the activities that you see at end of life, which in this particular case, we're looking right now so far at fairly common disposal mechanisms, for example, incineration without waste heat recovery. And then there was some recycling as a comparison. But those activities that are involved there will contribute to carbon impacts. They'll contribute to energy, water, and all of the environmental impacts. So that's one important thing to recognize about a life cycle assessment, is that all of the activities across the life cycle stage are going to be impacting these different impact categories. So you can, that's why it's important to look at the contributions across different impact categories, across the different life cycle stages. And that gets into a whole lot more granularity of technical detail that we'll be getting into later with more detailed technical reporting.
And in the LCA, is a single-use equipment landfilled or recycled?
Yeah, as I mentioned, so far our kind of default assumption for example, red bag type of waste would be incineration without heat recovery. We also think about landfill for some of the other materials. There is some recycling in the model so far, but what we are going to do as we continue the modeling throughout this year, we're going to be looking at a wider variety of end-of-life treatment options. So for example, we also want to look at incineration with energy recovery. We're going to look at more detailed recycling scenarios. And then we're also going to be looking at, obviously some of the waste streams are materials that have contacted fluid path, others packaging and things like that. So we'll be looking at fairly detailed end-of-life scenarios. So we have actually solicited input from some manufacturers about what their disposal mechanisms are, which of course vary based on geography. But we certainly invite input from others if they'd like to make sure that there's alignment with what we're doing with what your disposal practices are.
Okay. We have another question. It says, you mentioned minimal benefit from recycling consumables. What processes for recycling did you look at?
So far we're looking at fairly straightforward recycling of the materials. As we get further into this, as I'm sure the questioner knows, there could be a wide range of types of recycling involved, and it's going to be different obviously for the packaging. So we'll be looking much more specifically at that as we get further into the program. So we very much understand that a lot of folks are very interested in these programs, so we're supporting end-of-life activity. I want to make sure that we have the LCA modeling to help folks as they make decisions about some of those ongoing programs to deal with solid waste.
Okay. So we have another question. The question is, I didn't get at how many batches per year was considered in LCA modeling. And he says, I can imagine if you produce 220 or 200 batches per year per bioreactor, the environmental impact change quite dramatically, at least for the raw material used for the hardware.
That's a very good question, and I hope I can answer it clearly. The way we do the modeling, again, so there's a couple of issues here. One is the number of batches per campaign. And so our study, when we're comparing the different types of process technologies, single-use, traditional, and hybrid, we normalize against the same number of batches, so the same amount of product. As you can imagine, there are differences in the time scale with which you can execute a certain number of batches depending on your choice of process technology. So those time scales are normalized in. So essentially the environmental modeling is per unit product produced, and if the amount of product you produce per unit time can be different depending on your choice of process technology. So that is a whole nother discussion more related to productivity and performance. This study is really only comparing the environmental impact per unit molecule produced. And so the number of batches you do, everything is normalized to the amount of product you're producing. So the proportion of the hardware lifetime that you're consuming in a given batch, that's all prorated. So everything should adjust nicely, and you shouldn't have different results or different conclusions if you're making more batches per year or fewer batches per year. You will see differences in productivity and economics and things like that, but the environmental impacts we report are normalized to the unit quantity of product that you're making, the molecules.
Okay. So I'm going to combine a couple questions that are speaking of the same basic idea here. We have one question about the region and whether an arid landscape would be better for single use. My guess is on water use compared to not using water. And the other question is, I'm curious about the variability surrounding the geographical placement of single-use facilities as they relate to end-of-life impact estimates on environment and carbon footprint. So.
Okay, I'll tackle the first one first. So yeah, I think we're all a little bit concerned about what to do in arid regions where you have limited water We've seen some data that some of the larger scale manufacturing operations consume considerable amount of water, and that could be a limiting factor for certain geographies. What our data show is that the single-use technologies consume considerably less water. So that might be a factor you would think about if you wanted to localize manufacturing in an arid geography. In our modeling, the main things as we look at different geographies that are different, the things that are different in the model as we look at different geographies are essentially electricity consumption. Each area, each geography has a different mix of energy generating technologies. So for example, China is pretty heavy in coal. Other regions might be pretty heavy in renewables, and that's going to affect the environmental burden associated with your energy pull from the grid. So that's a big difference. Another thing that we shouldn't underestimate based on what we've seen so far is we see transport differences. So our supply chain right now, as currently configured, feeds into different geographies, and there are considerable differences in the amount of transport required to get everything to one geography versus another. And so that actually could be something that we take a look at pretty closely as we go through the modeling. There may be some optimization opportunities there. But as you see the differences in the different impact categories in different regions, right now in these preliminary results is largely due to differences in energy grid and differences in transport. As we get into end-of-life modeling, I think the way we're thinking about that is we will be looking at different end-of-life disposal mechanisms that are accepted or required in different geographies, and we'll try to cover as much space as we can.
Okay. Well, thank you so much, Bill and Amit, for joining us today, and thank you to the audience for joining us today. Just a reminder, this webinar will be available for on-demand replay on the multimedia section of the BioProcess International website. You can get to it just at the same place that you registered at www.bioprocessintl.com/bioprocessinsights. And with that, I'd like to thank everyone and have a great day.